is 4 minus 1, that's 3, quick maths. Everyday man's on the block.
So this morning we're going to be looking at finding the area of triangles, and similarly to when we were finding the area of rectangles, we are basically just going to be applying a set of formulas to find the area of the shapes. So as you know, we have different types of triangles, and no matter what type of triangle we have, it is basically the base of the triangle and the height of the triangle that I'm interested in when I'm trying to find the area. So consider maybe a right angle triangle that looks like this. Now what's something that I know about a right angle triangle? Massimo?
That one of the corners has a right angle.
Good. And what does a right angle mean?
It's 90 degrees from the base.
It's 90 degrees to the base. Perfect. So for this triangle here, which is a right angle triangle, that would be, if this was considered to be my height, then this here would be considered my base. Now consider this triangle, if it was rotated, so if I rotated it 90 degrees, so then that part there was my base, then all it would mean is that height there, that length there would be considered my height. Okay, so that's one type of triangle, that's a right angle triangle. I could also have an isosceles triangle. So what's something that we know about an isosceles triangle? Does anyone know what we know about an isosceles triangle? Charlie?
They've got two sides that are the same, but one side that is different.
Good. What do you mean by two sides being the same? What about those sides are the same?
They have the same measurement and length.
They have the same length. Good. Okay, so here's my isosceles triangle. And how can I show that two of the lengths are the same size? Yep. Yeah, we can do a little line like this to say that those two lengths are the same. Okay, now the perpendicular height could be drawn here. So if I wanted to find the area of this triangle, I would be interested in that perpendicular height as well as the base, which would be drawn down here. Okay, so we could have a whole range of triangles. We could also have a equilateral triangle. With an equilateral triangle, we know that all the sides are the same, opposed to the isosceles, in length I should say, opposed to the isosceles where only two of the sides are the same length. So, if I want to find the area of any triangle at all, if I know the base of the triangle, the base length of the triangle, and the height of the triangle, then I can find its area. So I know that the area of a triangle is equal to the base length times the height divided by 2. If we compare that to a square where it used to be the base times the height, there was no division by 2. Alright, so it's base times height divided by 2. Or sometimes you'll see it written as area is equal to half times base times height. They are exactly the same. Alright, so we'll just do a quick example. So find the area of the following triangles. So first we'll do a right angle triangle. And we'll say that this length here is 3 centimeters, and this length here is 5 centimeters. To find the area, do I need to know what the other length is? In a right angle triangle, we actually call this length here, which is the longest length, the hypotenuse of the triangle. Do I need to necessarily know what the length of that hypotenuse is to find the area? No, as long as I know the base and the perpendicular height, then I can find the area. So, set out our work clearly. Area is equal to base times height divided by 2. Start a new line of working. Our base here is 5 times our height, which is 3, divided by 2, which is going to be 15 divided by 2, which is 7.5. And what are my units? Yep. Now centimeters are units of length. This is area, so therefore it's good. Squared centimeters, centimeters squared. Okay, let's do one more example. What if I have a scalene triangle? What does it mean to have a scalene triangle? Does anyone know? Charlie?
Pretty sure that means none of the sides are the same length.
Correct. None of these sides are the same length. Okay, so I've drawn a shape where this length differs to this length, which differs to that length there. So this one here might be, say, 7 centimeters. Now, if that's the base, if I was to call this the base, to find the area, I need to know the perpendicular height. Therefore, I would need to know the distance or the length from there to there. That's the height of the triangle. So if that was maybe 2 centimeters, then to find the area, it's going to be base times height over 2. So I've called my base 7 times the height, which is 2, over 2. And we know that that's going to be 14 over 2, which is 7. Or you could simply just see that the two 2's cancel each other out, and you're left with 7. So we're left with 7 centimeters squared. Alright, and we'll leave that video there for today.